When an event is triggered for an element on the page, it may or may not be handled for that element. For instance, the mouse over event is not currently handled by any element on our page. Any unhandled event for an element is passed to its parent element. If the parent element doesn't handle the event, it continues to be passed up the DOM tree. This is referred to as bubbling up the DOM. Ultimately, an unhandled event will reach the document object and be disposed of if there is no handler present. There's a lot of discussion on the internet about the proper way to cancel an event. Keep in mind, an event handler is not supposed to return a value. Therefore, many feel that returning false is somehow messy or tainted. Of course, there's no reason that any future version of a browser should support canceling an event when false is returned, so they have a point. There is a JavaScript method available on the event called preventDefault. As the name implies, it will prevent the default behavior of the event when called. Consider an anchor tag with an href attribute. The normal behavior is for the browser to load the URL described in the href attribute. If preventDefault is called within a click event handler that is attached to the anchor tag, the browser will not load the URL. The default behavior will be prevented or canceled. Versions of Internet Explorer prior to IE9 did not support the preventDefault method. The only way to cancel an event was to return false from the event handler or set the event return value to false. When using jQuery, we can confidently make use of the preventDefault method. If a browser doesn't support the native preventDefault, jQuery will just return a false value. There are two jQuery methods available to us: stop propagation and stop immediate propagation. We'll take a look at how each of these work. We've added the clickable class to the work area div as well as the second paragraph tag. We now have nested clickable elements. This will let us follow how events are propagated up the DOM tree. We've changed the code a bit from the state it was previously in. Notice the anonymous handler function accepts a parameter that we've called event. jQuery passes the standard JavaScript event as a parameter to our anonymous function. We'll use the type property of the event parameter when creating our event message for display. This makes it cleaner than using the hand-coded strings of double-click and mouse down we had before. None of the event handlers currently return a value. That means all default processing will occur as expected. Let's see what happens as we click around on the page. First of all, we see that the click text is in lowercase. Before, we used a hard-coded string which was all uppercase. This shows that we are using the parameter value instead of our hard-coded string. Notice how the mouse down events fire for both the header and the containing div. Then the click events fire for each. That's because the header is a child element of the work area div. Both elements have the clickable class, so both elements have the click handler attached. Events process from the innermost to the outermost elements that contain handlers. If we click on something embedded deeper in the DOM, we see that the mouse down and click events do bubble up the DOM. All the mouse down events are processed before any of the click events are processed. This is important to know. Suppose we attach some processing to a mouse down event of the work area div that disabled our button. The mouse down event would fire for the button, then it would fire for the work area div. If we disabled the button in the mouse down event handler, the button click event will never fire. It will always be disabled. It's important to consider the order that events are processed if we have handlers on embedded elements as well as parent elements. Let's reload the page to erase the current messages and see what the double click looks like. The mouse down event is handled on the span, paragraph, and div prior to the click event. Then the next mouse down is handled prior to the second click event. Finally, the double click is handled for each of the elements going up the DOM. Incidentally, the text is being selected because we no longer have a return value of false on the mouse down event. Let's add it back in to see how that affects the order of events. We return false from within the mouse down event handler, just like we had it before. Only this time we have clickable elements within other clickable elements. The last time we tried this, no clickable element had a parent that was also clickable. Let's look at the results. Now we only get one mouse down event for each of the clicks that are part of the double click. The return value of false canceled the mouse down event. it didn't bubble up the DOM, and we see that the text we double-clicked was not selected. Keep in mind, some browsers may not support returning false from event handlers. If we leave our code as it is right now, there is no guarantee it will work properly in all browsers. That's not an error, since the W3C specification calls for no return value on the event handler. Of course, try explaining that to your boss or customer. To make things work as they expect, we would have to figure out which browser we're dealing with and make sure we take appropriate steps for those that don't support return values. Fortunately, the jQuery library can handle all this for us. One more note about bubbling. Those of you that know about event delegation will say that's the true description of event bubbling. That's correct. For our examples here though, I'm using bubbling as a description of how embedded elements handle events from the lowest to the highest hierarchy. In that regard, the event is bubbling up the DOM as well. We'll discuss delegation in the next section. The prevent default method can be used instead of returning a false value. Unfortunately, this can cause more confusion because it doesn't do the same thing as returning a value of false from the event handler. Let's remove the return value and replace it with prevent default. The prevent default method is called on the event that is passed to the mouse down handler. Prevent default is a method of the event object. It is not an intrinsic JavaScript function. To make use of it, we must use the parameter that is passed to the event handler function. Let's see the result. Let's start by clicking the embedded span within the second paragraph. Look at the messages. We got 3 mouse downs and 3 clicks. The prevent default didn't appear to do anything. Earlier, when we returned false, we only got 1 mouse down event along with 3 click events. What's going on? Let's refresh the browser to clear the messages, then try a double click. As expected, we got 2 mouse down events, 2 clicks, then 2 more mouse down events, then 2 more clicks, and finally 2 double clicks. The behavior is exactly the same as if we hadn't called the prevent default method at all. Well, not exactly. Notice that the header of the work area is not selected. Normally, a double click will select the text under the cursor. Calling prevent default avoided this behavior. It did not cancel the event. It just prevented the default behavior of the event. In this case, it prevented the selection of the text under the cursor. If we had prevented the default behavior of an anchor tag, the URL of the href attribute would not get loaded. If we had prevented the default behavior of a submit button, the page would not be submitted. All events up the DOM are still fired and processed. All the prevent default method does is prevent the default behavior of the element that triggered the event, but only in browsers that support it. Internet Explorer would still show selected text because it doesn't support the prevent default method. This can be very confusing because jQuery calls prevent default on the event object when it is available and returns a value of false for browsers that don't support it, mainly Internet Explorer. This causes different behavior to occur in different browsers. Which technique should be used? Many developers use prevent default as well as return a false value. This certainly covers the bases, but it's important to understand what is actually happening. There may be times when you just want to prevent the default behavior, like the selection of text on a double click, but you still want the event to be processed up the DOM tree. Returning a value of false will prevent the event from being processed by other elements. Let's talk about that for just a moment. How can we manage the event without resorting to returning a false value? We've already talked about how the prevent default method cancels the default behavior for the element in response to the event. What if we wanted no other elements to receive the event? That's where the stop propagation method comes in. When we call the stop propagation method on an event, it will not be passed up the DOM tree. Let's take a look at that. We'll add the stop propagation method to the event passed to the mouse down event handler. We're not using chaining on the event object because the stop propagation method doesn't return the event object to allow chaining. Incidentally, neither does the prevent default method. We have to specify the event object for each method we want to call on it. With these methods applied to the event, let's click around on the page. When we click the work area header, we see that the mouse down event is processed for the heading element, but not for the div. The event was not propagated or bubbled up the DOM. The same is true when we click the embedded clickable span. The mouse down event is only processed one time, regardless of how deep it resides within the DOM. It's important to realize that the stop propagation method stops the event from bubbling up the DOM. That means any parent elements will not receive the event. Any other handlers for the same event that are attached to the current element will still be processed, however. Let's add an additional mouse down event handler to illustrate this. This pattern may seem odd, but it's legitimate. More likely, in a real-world application, event handlers will be attached to the same element from various locations in the code. Here, we're illustrating how multiple handlers can be attached to the same element for the same event. For the second mouse down event handler, we'll just show the message and modify the suffix so we'll see that we're getting a message from the second handler. Let's run it. Even though the first mouse down event handler called the stop propagation method, the second mouse down event handler was still processed. That's because the second event handler is not farther up the DOM than the first. They're on the same element. To immediately stop all subsequent processing for an event, the stop immediate propagation method should be called. Let's change to use the stop immediate propagation method instead of stop propagation. Let's run it again and verify that the event does get cancelled for the current element. Just as we expected, the second mouse down event is not processed. We could prevent multiple click processing by adding the stop propagation or stop immediate propagation methods to the click event handler too. Since there are no other click event handlers attached to the elements, we could have used stop propagation instead. When should we use one over the other? Well, that depends on the project requirements. If we use stop immediate propagation, then any future code that tries to add a click event handler will not work properly. That may be what we want as we write this module, but it may not be what the next developer wants when they write the next module. If we use stop propagation, then any future event handlers will still process for this element. How can we satisfy both current and future needs? There is a way to have all the event handlers play nicely together. jQuery provides methods that determine if stop propagation or stop immediate propagation has been called for the current event. There is even a method to determine if prevent default has been called. We can check the results of these methods in our event handlers and only process the event if nothing has previously tried to stop propagation. The code has grown quite a bit because of the 3 conditionals on each event handler. We'll clean all this up in a minute, but notice how each event handler checks to make sure that nothing has requested to stop propagation or prevent the default prior to processing. With these checks in place, we can revert to using stop propagation so that future event handlers for this element can still process if they need to. Let's verify this all works before we move on. Notice how we only get a single mouse down and click event for each element we click. What about the double click? We see multiple double click messages because we haven't stopped propagation on that event. We've made a lot of code changes, but all the event handlers look pretty much the same. The shorthand methods are great for attaching a single event handler, but the code tends to duplicate like this when multiple events are attached to an element selector. We'll address that in the next section. We talked about how multiple handlers can be attached to a selector for the same event. We also showed how to stop propagation of the DOM and how to check if propagation has been stopped. Our code has grown with duplicate lines. You might be thinking it's time to write another function. Actually, it's time to talk about how event handlers can be attached without using the shorthand methods.